All right, so welcome everyone to the America's Imagery webinar series, working with drones. This is our last leg of the four-part series. If you missed, at least the last two are, the links are in the chat, advanced imagery and also um, imagery management. Um, I'll make sure to post the very first one we had, which was photogrammetry, into the chat before this meeting is over. We got a great one for you guys today. Kurt Schroepy, if you don't mind, Kurt and Kyle, turning on your videos. Kurt Schroepy, who's the Esri BD manager for imagery, is on the call today. There's Kurt saying hi. Kyle Talbot is also on the call, who's a senior solution engineer from the imagery remote sensing team. Sorry, let me. And these two gentlemen will be giving their portions of working with drones on this call. So without further ado, I'm going to pass it over to Kurt. As a quick reminder, while they're presenting, feel free to drop any questions into the chat. You can send them to me directly, or you can post to everyone in the group, and we'll try to get to them as quickly as possible. If not, we did reserve time in the back end of the presentations. I think we have about 20 minutes today to do Q&A, so we will be answering those live. So with that said, I'm gonna kick it over to Kurt, and we'll go for about another hour or so, and then go into the Q&A.
Excellent. Hey, thanks, Milk, and thank you to everybody who's come to these different webinars that we've been holding throughout the last 2 weeks. We really appreciate everybody taking a look at what we have to offer when it comes to imagery inside of ArcGIS. I was telling Milk before things kicked off that we saved the best for last, and he asked me, is that speaker or content? And so I just decided to let the audience decide what that's going to be. So, but we are looking forward, Kyle and I both looking forward to presenting to you today. I'm going to go ahead and stop my video just because of bandwidth issues, and then we'll just jump right into the presentation. One of the things that I love with Esri is our notion around the science of where. It's so descriptive of what we want to do, and but as an imagery guy, what excites me the most is that the science of where, in my opinion, really starts with remote sensing. And it's the ability to send out all types of different sensors, go out and collect information about built environments and natural environments. And with the advent of drones, it's even more exciting because now, just for a very little amount of money and a simple implementation, you can literally carry around a complete mapping system in the trunk of your car and just about go any place, launch a drone, go out and start doing some beautiful 3D mapping. We're just going to show you some great examples and how that all works for you today. So, it's just a natural extension of the science aware. As Milk was talking, we've covered lots of different topics over the past 2 weeks with the different webinars. And this slide is designed to kind of narrow those down into just 4 broad categories. The first one being able to take all this rich content, manage it inside of a platform, and then, of course, being able to take those raw sources and do mapping. And it's more than just, straight ortho mapping. It's also the 3D mapping, the 3D aspects of it. That's becoming more and more important. So it's this ability to take raw content, do the mapping in multiple dimensions, but now we're taking that even further. We're getting into making observations. And then more important, what Vinay was showing and Kyle was showing just on Tuesday, was this ability of the computer to go out and find these spatial patterns within this remotely sensed content and be able to generate information products on the fly using the technology. So that's really what the ArcGIS platform is all about. One of the things that we kind of haven't covered, we did these webinars kind of piecemeal, and we covered all these different aspects. So I wanted to bring in this slide just to kind of show you how the complete platform comes together. And this might be scary, it might seem a little complicated, but it really isn't. Essentially on the left-hand side there, those are all your sources. We bring those into the system, as they were talking about in imagery management, as a mosaic data set. And the mosaic data set does nothing more but manage all the metadata associated with all those pixels and allow the system to go out and find the pixels that it needs to do the ortho rectification, the feature extraction, the change detection, whatever it might need to do. Now, a key part of that is making sure that that imagery is as accurate as a map. It needs to be very geospatially accurate. And Steve Lambert did a tremendous job showing our ortho mapper tools. And those are traditional photogrammetry tools, work with aerial, works with satellite, and will also work with drone imagery. But we also have our new drone collections, and that's really what today's webinar is about, is those drone capabilities. And we're going to make some distinctions on why you would consider a drone capability like drone to map or site scan over the ortho mapping capability. And we'll talk about that as we go through the presentation. Another aspect of this presentation, we've talked about, the high-end image processing, the imagery analyst, but we also want to show you a very simple web client that we've put together that makes imagery exploitation much easier for multiple folks. And so it leverages imagery services. So if you imagine you go out and you collect a whole bunch of imagery, you want to give people access to it. We have a new product called Excalibur that provides that access in that very basic image processing functionality. And Kyle will be showing that as we go through the demonstration. But it's all about transforming raw sources of imagery into useful information. Now, in the past, this has been somewhat complex. Remote sensing is not for the faint of heart. Photogrammetry can be a very challenging, highly mathematical thing. But at Esri, we've been working extremely hard to flatten that complexity curve. We've really spent a lot of time and effort trying to make these complex things simple. And hopefully you'll see that as we go through the products today. Drone to map, site scan especially, Excalibur, these have all been set up trying to make these things simple and easy to use. And as I was talking about, Excalibur is this tool to do this visualization and what we call exploitation of the imagery. It's primarily is only for visual exploitation, so it doesn't have a lot of analytics behind it. But what it does do is provide this great visualization and ability to go in and work with the imagery, search and discover, look for it, make your observations, do some basic change comparison, and then actually populate different activities through an operational dashboard, whatever it might be. And Kyle's going to jump in and he'll show you those capabilities. It's a nifty little tool. It's very low cost. But it's something that we see that will continue to grow for those people and those individuals that don't need a full-up ArcGIS Pro to do their image processing work. So let's jump into the main topic right now and talk about the drones. And what I love about drones is they really truly are a new window on the world. They provide this high-quality, extremely accurate, easy-to-use solution that really is surprisingly low cost. I mean, you can go out and get a drone for under $1,000 in some processing software, and you can make some extremely powerful 3D maps. Now, the one thing about drones where it's different than aerial or satellite is they're primarily for what I call micro geographies. These are smaller areas of interest. It could be a site like this, like a dam, or it could be a building or a structure. We have one customer, they're making 3D maps of their landfill so they can estimate how much capacity they have still in their landfill. So they just fly it once a month and they see how full their landfill's getting. That's a microgeography. But it's solving problems from them, looking at smaller areas that they need to know. So it can be a powerful solution. There's 3 primary product types that can be made from drones. The first one being those 2D image maps, and those include the orthos and the DSMs. The 3D elevation products, so you can look at it and work with the data in 3D. And then these inspection photos. You know, a lot of times you don't necessarily care about the geospatial referencing. You just want to see, you know, if there's any rust damage on this bridge, or, you know, does this shingles are missing on this roof, or whatever it might be. So people want to do these different inspection type stuff. So that's what our software is designed to do, is those three things. Now, we talked about, you know, Steve Lambert gave a great presentation on our high-end, very rich photogrammetric capabilities. And traditionally, the way that's done is using something called areotriangulation, where it goes in and it just matches all the images up and produces a mathematical model about those images. Traditional photogrammetry, traditional triangulation, it really likes to have images that are taken as near vertical as possible. In other words, looking straight down. That's the way it works best. But what we've done with the drones is come out with a new way of doing the triangulation. In other words, creating the 3D mathematical models between all your imagery. And that's something called structure from motion. You might have heard of that before. All the drone capabilities that we're going to show you today use structure from motion for its photogrammetric engine. And because it can do that, it can work with imagery that is not taken straight down. It can be imagery taken oblique on the side, and it matches it all together mathematically. And that's how we're able to get these very rich 3D products. We can generate highly detailed point clouds and 3D meshes from drone imagery that you can't get with standard traditional aerial photography. So that's kind of how we separate the difference between all our drone work and the photogrammetry that Steve Lambert showed a couple weeks ago. So there's the two differences. And then because of that structure from motion, you can see now the different types of information products that can be generated from these drone packages. You know, yes, we got the orthomosaics, we got the DSMs, the digital surface models, we can generate contours. Those are kind of traditional photogrammetry things. But on the 3D side, as I was talking about before, very detailed point clouds, the 3D meshes for site models. We can publish those site models as scene layer packages so we can work with them in web clients, you know, on the internet. This is very powerful. And then we can also use that same mathematical modeling for the inspect and measure side of things, whether it's volumetric measurements where we can calculate the changes in different volumes. You know, maybe we have a debris pile that we need to estimate on how much it would take to clear. We have those tools and they're available because of the technology of that structure from motion using with the drone imagery. Now, these are just some sample products made by our customers that we'd like to show. Extremely detailed. You can see this particular project, you know, 4,800 images that were processed in our drone to map software. And you can see the very detailed information that we were able to derive of this airfield down in a place in Southern Virginia. And they were looking at extending the length of this runway. And so they needed these 3D products to be able to do that kind of work with the, you know, how to figure out how best to expand that runway. This sample product, this is actually the Esri campus in Redlands, California. We're adding a new building. We have more developers coming on board. And so once a week, as a rule, they have been going out and using our drone capability, fly over the construction site and maintain this progress of this construction as they're creating this building. And these are some of the different information products that are generated that have been made as part of this collection. You can see the boulders in the center of those images. You know, Jack is a landscape architect, loves to have his boulders, you know, and bring natural views inside his building structures. And so, you know, they're smart. They put the boulders in first and then built the building around the boulders. So it's kind of exciting to be able to visualize that with the drone imagery. This is just an example of that high resolution 3D mesh that you can get. It's perfect for site planning, facilities management, those types of things. And then, as you know, before we started and kicked off the presentation, I'll be actually working with FEMA over the next few days as we go through this crisis support with Hurricane Laura. This is actually drone imagery that we took over Mexico Beach, Florida from Hurricane Michael a couple years ago. And you can just see, how accurate that drone imagery is. And you can see the devastation that occurred in that imagery. And, these drones can get up there immediately and start doing this very precise 3D mapping to just measure the extent of damage that occurs after a disaster area. So there's a number of these different applications that can be used, and more as different organizations get access to drones and start using them, they're finding more and more applications, and it continues to be a huge growth area for us at Esri. Now, the one thing that I would like to add, in addition to all that great stuff, is, as imagery folks, we want to make sure that our imagery is as authoritative as possible. And so we need to ensure accuracy. And that's where these comprehensive processing reports that are produced by both our drone to map and our site scan solution are made available. So you can actually go in there and you can look at these reports and you can see in detail what the accuracy specification is on all your products. And this is in turn allows you to make them authoritative. So when you go out there and share them with your users and you start doing different work or analysis with it, you know that it's geospatially accurate for the types of things that you need to do. So first I'm going to just jump into drone to map, and we're just going to cover drone to map very quickly. Drone to map is a standalone PC application. It doesn't need any other ArcGIS software. It works with other ArcGIS software, but you don't need it. It stands alone. It runs in Windows, so it can work on a PC, and it does this very high-end, drone type photogrammetry. And here you can see this is the user interface, and it allows you to set up different projects. It's project driven, and these projects can be 2D projects, 3D projects, or even inspection type work. And you distinguish those because creating 3D output can be a much more consuming than just 2D output. So it allows you to select the different types of products that you want to make. And so it's just a matter of identifying where your photos are from the drone that was taken. You got to make sure that those photos have X, Y, and Z values with them, because that gives you your initial orientation around those photos. And then you can just see how this flight line was collected by the drone. And at any point, you can go in and click on any of those little blue bubbles there, and you can see the actual photo that makes up that area. And you can see we have good overlap in this particular collection. And so we can generate some halfway decent 3D products by making sure that we have this overlap. And then this is the tool that allows us to bring in ground control points. So you see that X, that marks the spot. And so what I've done is I've told the computer that this photo is marked at that exact location. And that ensures true 3D accuracy of my products. So on different surveyed in points, we've had accuracy down to 3 centimeters in 3D using drone and surveying type techniques. So it's very powerful. And these are just the different options that you have on the settings on how you want to produce your products. So you have complete ability to kind of set up and how you want the processing to work and the level of detail and those types of things. So once you're done, you just kick off the process, and hopefully you have a powerful enough PC to run the information. And here you can see the result. So this is the drone imagery, high resolution, compared against the backdrop imagery of our base map. And you can see the level of detail and the accuracy that you get when you use those products. Now here you'll see that was a DEM and this is a DSM. So what the solution will allow you to do is it actually tries to figure out the bare earth model that gets created in your 3D products. So it'll look at a DSM or a DTM. And the DTM is the bare earth. The DSM is the digital surface, which includes everything, the bushes, the buildings, and everything. Now, this particular flight pattern was done to do work in 3D. So you can see the nice thing about drone to map, it allows you to work and visualize in 3D. You can see I did orbital pattern around this particular building, this facility. And I took it from different altitudes and I set my gimbal on my drone to look at different look angles. And so because of that, I got very nice 3D type products. So you can see that facility there. And so It just kind of depends on the different information products that you want. If you're happy with orthos, with good 3D but not high end in site modeling, then you can fly this lawnmower pattern going back and forth. But if you want good 3D, it's good to do an orbital pattern. Now, what's really nice here is all this output can be published with just one button, either into ArcGIS Online, or you can open it up inside of Pro. So the solution doesn't need Pro, but it will work with Pro automatically. And so I just click on this, open my project up in Pro, and the system automatically goes out. It opens Pro. The system will point to where your drone project information is, and it will bring all that data right inside of Pro and give you all the different powerful image processing tools that Vinay and Kyle and others have shown you in the different webinars. So, once the imagery is processed through drone to map or through site scan, you bring it in and all your traditional image processing works just fine. So that's what this little diagram is designed to present. Just with one click, you got drone to map, you can publish your project into Pro, or you can publish the information products to include the 3D products into your ArcGIS Online or your portal. So it works seamlessly as part of a complete solution for the platform. Now, I've been talking about drone to map, and as I mentioned, and I talked about, drone to map is a standalone product that works on a Windows PC. But a lot of our users came back and said, we need something more. There are some cases where I want to operate in a disconnected environment, and all that's good, and I can use drone to map for that. But most of the projects we're doing are very big. We're working in connected environments. As an organization, I might have 10, 15 drone pilots. And we don't want multiple copies of drone to map. We want a centralized kind of processing environment to do that. So Esri went out and we acquired a company by the name of SiteScan. And we got 3DR, and they had a software package called SiteScan. And we have now acquired SiteScan, and we are now starting to integrate that as part of the ArcGIS platform. Now, the thing that makes SiteScan different is that it is a true software as a service product. In other words, you don't have any software running on your computer. This is software that all runs in the cloud. You go out, you fly your drone, you collect your imagery, you push your imagery into the cloud, and you start processing. And the thing that is very powerful about this is that it is fully scalable. So it can scale not only across the organization, so you can have multiple drone operators flying drones and publishing their raw products for processing in a centralized location, but it also scales as far as data storage and processing goes. So the more data that gets thrown for processing, the more CPUs are automatically spun up to do that processing work. So, let's face it, not everybody can go out and get a extremely powerful PC with a powerful CPU and GPUs to do high-end 3D drone processing. So this is where the cloud comes in. I push the imagery up in the cloud, and I can take advantage of the most powerful computers that are available in Amazon or Azure and do my processing of my data. And I don't have to worry about it. I say process, I let it go, and I get an email a few hours later that tells me my work is done. And Kyle's going to show you how that all works and comes together. It's very powerful. But you can see now how we've pushed this capability from a standalone single user type operation with drone to map up into SiteScan for ArcGIS that offers this whole full up cloud processing. And what we actually have done is we have 4 different bundles of capability now that we offer that your distributor within your country can make available to you. At the basic level, we have drone to map with an ArcGIS Online capability that you can use. And then we graduate that up with more and more capability depending on the amount of processing that you need. So these are just 4 different bundles that you can acquire and each one of them adds more and more capabilities. And it's a complete range of processing capabilities depending on your needs as an organization. So before we get going more into the processing, especially around SiteScan, I want to talk about what we call TCPED. That stands for tasking, collecting, processing, exploitation, and dissemination. This is a traditional imagery workflow that's been around for a long, long time. It dates back to actually World War II, when aerial reconnaissance started up, and they would send out a tasking mission, and they would go collect photography, do the processing. The analysts would look at it and do exploitation, and then the information products would be disseminated. That same workflow still applies today, and it still applies with drones. But I bring it here to your attention because I want to highlight kind of where things get separated out within the product line itself. So if you look at drone to map is only really capable of doing the last three of these functions on this workflow: the processing, the exploitation, and the dissemination. But when you get SiteScan also includes the tasking and collecting capabilities. And so this allows you to set up mission areas that you want to collect and then be able to send the drone out to do that collection. And so it's cool. We got an app that allows you to do this. And this app runs on an iPad and Apple iOS, and it allows you to designate your area of interest and then set up a collection pattern. And the collection pattern can vary on the type of information product you want to collect. And so let's just jump into a quick little demo of this product, and so you can see how this collection product works. So this is what we call SiteScan Field, and you can go in and designate your project, and then you can look at different ways of flying. So you might want to just do an area survey back and forth, or you might want to do a crosshatch pattern like this. So with that crosshatch pattern, you get imagery from both front and side. You get imagery looking straight down, but also front and back and side to side. And so this is a good way of doing orthos, but also getting good 3D information. Now you can see as you adjust the different parameters, it automatically will tell you it's only going to take one battery. It's going to take 18 minutes. If you go up in altitude, then you don't need as many flight lines, but you lose the resolution. But the system's fully dynamic, so you can adjust those and collect how you want it to collect. And so once you get your area of interest, you just say, go ahead, collect this area. And once you're ready to go, you just hit the button and say, go out and fly it, drone. And the drone becomes a robot, and it goes and does what it needs to do. Another collection pattern that it can do is a 3D collection pattern. And we can go in, and you can see this allows you to set up multiple altitudes to collect around a particular area. So there's this very high bridge in California, and we want to do inspections, and you can see that we've set up an orbital pattern around this bridge so we can look at it from multiple different look angles. And like I said, once we're ready to go, the system goes through a check of your drone. And because I recorded this inside, the pre-flight check failed, but that's the power of it. It will actually go in and do that pre-flight and make sure everything's ready to go. And if you are ready to go and the system and the drone is ready, you just hit that button, say take off, and you let the robot be the robot, and it goes out and it collects the information exactly how you want to collect it. So it's a very powerful flight planning, flight management application. So that's the tasking and collection. What I'm going to do now is turn the presentation over to Kyle, and he's going to show you now how SiteScan will do that processing, exploitation, and dissemination. So Kyle, it's all yours.
All right, Kurt. And I will turn the question answering over to you. All right. So let's jump into SiteScan here. Kurt did a great job showing an introduction to the flight planning application. Great for tasking and collection. I'm going to show you this the second part of SiteScan, what we call the SiteScan Manager, which you'll see here is completely accessible in a browser. The SiteScan app is very helpful for that first part of the TCPED workflow. However, if you are able to completely run a full drone processing workflow in the browser here, in the SiteScan manager, especially if somebody else is doing the task and collection of your drone images, and you're just simply looking to do the processing on your own. So this is our home page of our SiteScan organization. An organization is very similar to ArcGIS Online, ArcGIS Enterprise, with many different users and members. That's how SiteScan works as well. Members and licenses will be added to your organization, and so you can collaborate with team members on your various projects in this org. You can add certain members to certain projects. Some people have full access to all projects. It's based on your permission levels. Again, very similar to user types, permission levels at ArcGIS Online and Enterprise. So this is where you can do the management of the different users. Here's where you can access projects that have already been run, or you can access you can create new projects as well. I'll walk you through the process really quick of starting a new project. So so that I remember what this is for. So we can give it a project name, give it the unit settings, etc. Move next. Then we can pick an area that we want to focus on. You can type in an address, and it'll essentially search for it for you. So what this does at the beginning is it just gives you a starting point, just where your imagery can focus on. And the reason we do that is because, as you'll see, a project can contain multiple flights, and these can be for multiple flies over the same area. For example, if you're doing like what we showed with building management during construction, and you're doing multiple flights, you can compare those images over time. If you're doing multiple flights over for certain purposes over a similar area, then it's nice to be able to organize them all into a single project. And then the last step, you can invite members of the organization right off the bat into your project. You can skip that step. And then here's your project. Here's your flights, and we'll show you this. We'll show you this completed project. You can add your flights here. We'll add one of those. You can add ground control points to increase the accuracy of your project, of your flights. Members here, output settings. This is what I'll start with first. You can start these outputs. You can change the default output settings of your different projects, so that because a lot of what SiteScan does is automatically run and process, and so if you were to change the by changing the output settings here, then you don't have to do any reprocessing later on if your desired outputs are different. So we can set these different, again, depending on what, we can change the size of our point cloud, we can change the resolution of our orthomosaics, identify which mesh engine we want to use, etc. We can add all of that. And then I'm going to go ahead and add a new flight. This is really easy. All you have to do is give it a name, give it a date. Oops. We'll do today the 27th. And then you start uploading photos. Again, I'll just find some photos from a prior project here. You can go ahead and select all of the images. And then the first thing that it's going to do is it's going to start to dedupe. It's just going to check and make sure there aren't any duplicate images in the batch, and then it'll start to upload. Upload times are based on the speed of your internet that you're working with. So once the images are uploaded, you can check. You can check this box that will say automatically process when the upload completes. That's why it's important to set your output settings at the beginning of your project, because it's going to process all of this information based off of the settings that you've identified in your project. So we can do that. You do need to leave this window open while the images are uploading, but that doesn't mean you can't open another browser window of SiteScan and continue working in other places. And the beauty of SiteScan is it just does it on its own, right? So what we'll do, actually, go to our project list so you can see. We're going to go to one project. This is the bridge that Kurt showed the video of, the flight planning application. So this is the output. The nice thing about working with SiteScan from the flight planning app is that it will just, once you have the flight completed, you send the photos up to the cloud from there, and they just immediately start processing. You don't even have to go through this step using the flight planning app. So we'll open up so you can see the flights, the different flight plans, again, the output settings, members of the project, etc. We'll just jump into one of the finalized flights. And so you can see now the seamless orthomosaic is very high quality, much higher quality than the base map behind it. You do get to see the individual photos as well that were taken, uploaded into the project, all of which are downloadable, exportable on their own. You're not only creating orthomosaics, but generated from the point cloud, which I'll show you in a minute, you can also create different elevation data. And so that includes things like contour lines, elevation models, cut fills, and hill shades. So lots of accuracy there. You also generate a point cloud using that structure from motion algorithm that Kurt mentioned earlier in the webinar. It's able to generate all of these different points. This is great for visualization. However, SiteScan also gives you some tools for easy analysis. You can use an elevation profile tool. We're working in a canyon here, so I can drop a point, move that point, move my line up to the top of the hill here, and it gives me that elevation profile that I can use. Another nice tool is the photo inspect tool. So what this does is it'll let me select a point anywhere here in the point cloud. And after I select a point, all of the corresponding images where that point falls, the individual images, are given to me in the side pane here, and I can use those for manual inspections. So a very handy tool. And then finally, overlaying the imagery over the point cloud, we're able to generate a 3D model, a mesh that we can use for visualization of the area. Again, this can be used for various modeling purposes. Pretty high resolution of this bridge. I did want to show you another project. This is one that was completed fairly recently. Just another use case. This is a project that was taken in Michigan. A few months ago in Michigan, there was a dam burst. And the dam burst caused a lot of flooding over this area. Lots of damage to homes. The FEMA agency in the U.S., Flood Emergency Management Agency, had to do a lot of damage assessment in this area. And so, again, when you turn off and on the orthomosaic, you can see quite a bit of damage has occurred after this flood. The easiest way to see that is through our timeline. So let's see. So the timeline provides a swipe tool, allows you to compare what the dam looked like before, as well as all of the damage that's occurred in this area. And you can just see going down on the roads is what people are dealing with. Now, I want to go to the mesh here really quickly, show the 3D mesh of this area. One of the things that FEMA will do as part of disaster relief management, et cetera, for disasters like this is debris from all the damaged homes, vehicles, structures, et cetera. Debris piles will be gathered up, and based off of estimations of the amount of debris in these piles will help to determine what insurance companies should help pay for disaster claims, et cetera. And so in this 3D image, you can see a lot of the debris piles that have been collected here. So you can visualize that. If we go back into 2D though, again, because SiteScan processed all of this elevation data, the different elevation models here, what we're able to do, and you can see it, you can see some of the outlines of some of these debris piles actually, the higher volume content. What we can actually do is we can actually use a volume measurement tool here in SiteScan to be able to visualize and get better measurements off of the volume contents. And SiteScan lets you see the cut fills of that in 3D. So very helpful tools for these types of workflows right here in SiteScan. So finally, what I want to do, I did get a question addressed to me privately about what we're doing as far as sharing these outputs, correct? So you have a couple different ways of doing that. One, you can export your data locally. You can download all of the generated products, the orthomosaics, the DEMs, the DTMs, contours, point clouds, meshes, the PDF of your processing report even, and the individual photos. All of that is downloadable. However, what we're also doing is we're connecting this to ArcGIS Online and ArcGIS Enterprise. So for now, what we're able to do is we're able to connect to ArcGIS Online, and we can share all of these layers as tiles. or your meshes as scene layers. You're able to do the same thing with ArcGIS Enterprise as well. You can connect a single enterprise deployment. You can connect a single enterprise deployment to your site scan org and publish information there. I did get a question about publishing them as image services as opposed to tile layers. That is forthcoming. That is on the roadmap. We actually just barely, as of a couple months ago, were able to integrate the enterprise sharing into SiteScan. So tile layers came first. Next up is image services. So that is a brief introduction to SiteScan. Pretty straightforward workflows with powerful cloud processing. And again, it's very nice to be able to just, once these photos are uploaded into your projects, into your flights, you can even close the browser and let SiteScan run on its own, and it just sends you an email when it's completed. That's the power of the cloud. Elastic processing, much more streamlined. So with that, I'm going to take a break from the drone processing software, and I'm going to move into the product that Kurt brought up at the very beginning, ArcGIS Excalibur, and an introduction to that and how you can be used to manage your imagery. So ArcGIS Excalibur is a web-based image client used for working with imagery in your organization. You can access it from your portal homepage. It is software that is directly tied to an ArcGIS Enterprise and image server deployment of 10.7 or higher. And what it lets you do is it lets you work with your image services, in your organization. So, kind of alluding to what I'd gone over earlier, there isn't a direct, easy button quite yet to get your imagery as image services from SiteScan. It is on the roadmap. It is coming, and there are other ways where you can still generate image services from your SiteScan products. For the time being, it just involves a couple of extra steps right now by downloading it and then uploading it again through ArcGIS Pro. So this is all of the imagery within our organization. Again, I'm just going to do a quick introduction to this, but you can connect with different imagery layers. You have cataloging capabilities where these image services that contain multiple different images, using the Mosaic dataset functionality, allows you to go through and search different images within your collection. And so you can do that by adjusting your search settings, by drawing areas of interest. You have filters such as date ranges, cloud cover filters, etc. This is all based off of the metadata within the imagery that you get. So sometimes, depending on the drone that you're flying and the camera, they may not have all of this information here that you can use for search and discovery. However, you can always draw by area of interest, and you can always view the metadata of each individual image to ensure that it's what you want to work with. And you can always preview what the raw image looks like as well. So this is satellite imagery that we have over San Francisco. Different from drones, but again, Excalibur will let you manage and work with all of the image services within your organization. So we'll show you an example of that. Let's see. Okay. So this is an example of drone imagery that was taken, a drone collection. So you can see all of the individual images. We can work with them here. In Excalibur, we can work with the whole seam of images as well. And you can see, again, Excalibur is a good tool for easily visualizing this imagery within a browser. And then again, you have all of the tools that you need to do some basic exploitation in this: markups, measurement tools, image display and enhancements, etc. And Excalibur will take in all types of imagery, not just your standard multispectral, RGB, panchromatic images, but they will also ingest other types of rasters. This is the DEM that was generated from that same drone collect. We intake all types of data types: thermal imagery, radar. We're able to ingest it all and work with it in Pro. You can work with it ad hoc, as I've shown. You're also able to create imagery projects. This is where I can go ahead and pre-select all of the different images and assign projects to individuals in my organization, and give them the specific tools that they need to access this information. And I don't know why this isn't working. I apologize. This worked yesterday. All right. Well, I think I'm going to press on then. So that's an introduction to Excalibur. There's one more thing that I wanted to show. This is our, going back to working with drones. We've talked a lot about working with the still imagery that drones were able to capture. We did want to introduce one more tool that we have for working with what you can capture with drones, and this is what we refer to as full motion video, also known as motion imagery. This is a capability that comes with the Image Analyst extension in ArcGIS Pro. This is something that has become very popular. It's primarily been designed for our defense and intelligence community, for what they're doing with motion imagery. It has become a topic of demand, or something in high demand from our public safety community. They want to be able to work with images from drones for public safety purposes. Right now, the motion imagery does require a data standard called MISB, which essentially requires specific metadata to be embedded directly within the video. And so what that metadata does is it allows you to project the field of view onto your maps and 3D scenes, as well as see what the line of sight, as well as the position of the sensor is as it flies, as the video plays. And so what this does is it allows you to transfer some of the information that you're getting from the video directly into your map and scene, and vice versa. information that you have in your GIS can also be overlaid onto the video. So for example, as this video follows a car here, what we can do is we can drop points on the car directly in the video that will kind of indicate breadcrumbs. Show where the car has been, follow its path. And as you can see that as I'm dropping these points in the video, they're appearing in the map as best as the metadata of the video allows. One other thing that we can do is we can take a single frame from the video, and with a single click, we can save that video frame as a single image, and it will automatically orthorectify that image onto the map. So there are various different tools that you can use with FMV in the video player. You know, things like a north arrow to show the direction of the video, measurement tools as well. So I can measure the distance of the car. Etc. So, okay, there we go. So we can measure the distance of the car, and then there are various different tools for exporting these different frames from the images, these frames from the video into different formats, such as saved file folders. You can export them into PowerPoints. You can visualize the metadata of these videos as well. So that is an introduction to some of the things that you can do with your drones. So with that, I think I'm going to turn it back over to Kurt to finish off.
Okay, thanks, Kyle. Actually, I'm going to go ahead and bring Milk back in as well. I think that's what we had to show for today. And, now it's a good time. If anybody has any questions, feel free to put them in the chat box and we'll answer them as good as we can.
All right, thanks, Kyle. Thanks, Kurt. Those presentations were fantastic, and as you've seen, Kurt, we've been pretty active on the chat. So we'll get to those in just a second. We had quite a few participants join this very last session. I would like to ask if you've done it for previous sessions. I kind of take these session by session, but your feedback is very much important. If you've enjoyed these sessions that we've been having, and we would like more, whether imagery or something else, please, again, class participation, pull out your phones, scan this QR code, and let us know what you thought of this session, and if you would like to be contacted or need additional support. All right, now that little infomercial is out of the way, now let's talk some different imagery questions. So I'm gonna pull up the chat here, Kurt. I know there was several, some that we missed, some that were asked in Spanish, and perhaps more you looked over.
Yeah, I can't answer the one in Spanish. Sorry.
He's maybe slap that one into Google Translate.
Looks like it has to deal with different band combinations and shortwave infrared.
Yes. Yeah, that's what I'm getting out of it. Does it require for you to adjust the camera angle? Is that last portion?
Well, when it comes to working with multiple bands, it really depends on the camera itself. The more modern cameras, the multiple bands will line up, perfectly, so you don't have to adjust those. Both site scan and drone to map can bring in imagery